Alright, we're going to do a practice problem using the washer method here. So this one says find the volume of the figure as it's rotated about the y-axis, and I have a little trig note out beside that may be useful in a little bit. But we have the region under the curve tangent of y, and that runs from, it's in the first quadrant running over to x equals 1, but we're going to rotate that around the y-axis. So remember, if we go around the y-axis, we'll write everything in y. So the way this thing looks, from the y-axis, we have a large, it's not very good colorful, is it? We have a large radius going all the way out to where x is 1. So this radius here, the large radius is 1. That's the outer. And then we have a smaller radius, let's see here, the inner radius going out to the curve. Okay, and that radius there is the little r, and it looks like it will be tangent of y, since we want things in terms of y. So that's our inner. So when we make a little washer, from the center, there's an outer radius, the big R, and then there's an inner radius, the little r, and that's what I'm talking about. Okay, so let's set this up. So we'll have an integration, but we'll have pi, we'll just pull it to the front of. Now in terms of y, it looks like it's going to go from 0 to pi over 4. Okay, because we're going to integrate in terms of y, so we want our endpoints to be in terms of y. So limits or bounds from 0 to pi over 4. Okay, and then we're going to have the outer radius, which is 1, and that will be squared. And then we'll have the minus the inner radius, which is tangent of y, and that will be squared, and dy. Okay, so just a little bit of note here. Tangent squared is something that is a little bit interesting to integrate, and we've never done that at this point in this course. So what I'm going to do is kind of go back up here to the note. Tangent squared plus 1 equals secant squared, and that's a variation of the Pythagorean theorem. So if we take that just to work with, tangent squared plus 1 equals secant squared, we can isolate that tangent squared. And even since this thing is subtracted up here, let's do that. Let's say 1 minus secant squared of x equals negative tangent squared of x. So I can replace negative tangent squared with 1 minus secant squared. So let's do that. So the direct substitution of that will still be from 0 to pi over 4, but it'll be 1 plus 1 minus secant squared of y dy. So it'll make sense to go ahead and combine those two ones. We could have done that before, but what our integral before we actually integrate will look like pi times the integral from 0 to pi over 4 of 2 minus secant squared of y dy, which is a fairly simple integral. So the pi will stay there, 2 becomes 2y. The integral of secant squared is tangent, so this will be minus tangent of y. So we're not getting away from the tangent, but it's still around. And then it'll be from 0 to pi over 4. Okay. But integrating the tangent squared, a hard problem. Integrating the secant squared, easy problem. Okay. So let's go ahead and put our endpoints in. So we'll let y equal pi over 4. So we'll have pi times 2 times pi over 4 will be pi over 2 minus the tangent of pi over 4. Okay, and go ahead right now, tangent of pi over 4 is 1. You can use your calculator if you need to. But then we need to plug in, let y equal 0. So minus pi times 2 times 0 is 0. and the tangent of 0 is 0. So this whole thing over here is 0. So it looks like we get pi squared over 2 minus pi when we distribute. Okay, pi squared, because we're going to push this pi in. So pi squared over 2 minus pi. If we want to figure that out as a decimal, it feels like we may have seen this number before. No, I haven't seen this number before. Let's see. This is approximately, if you like it, 1.79. So that would be the volume of the figure rotated around there. All right. So good job.